Hello everyone, good afternoon. Thank you for joining us for this last session of the day. I was speaking to Daniel earlier and I said we're up last, so we need to make sure we have plenty of energy and keep things going. So if I haven't met you before, hello, my name is Craig Steele. So my background is building apps and games and websites, but what I'm really interested in is helping people learn new digital skills. So we run short courses that are all about covering everything from the basics of using computers right through to more advanced topics as well. So we do topics including cybersecurity, AI, and working with data. But I'm interested in how we can prepare digital leaders and more people to understand the dangers of biased algorithms. And I think that to fight that inequality, people need to know how to spot these and learn how to tackle them. Running the workshop with me today is Daniel.
Yep. Hi, everyone. Nice to meet you. I know quite a few people in the room. It's really nice to meet for the first time. If not, my background is in engineering and electronics. They're into cybersecurity. And when I was studying these, whether it was at school or at uni or doing other professional qualifications, ethics was always a bit of a thing on the side. It was a bit of an afterthought. It was a module that you did at the end, separate to everything else. And that got me thinking, why are we not learning ethics at the same time we're building these other skills? So what I really wanted to do was build some educational resources that taught ethics at the same time that you were learning programming, the same time you're learning about data and AI. And we created Tech We Trust to try and help with that problem.
So here's the plan for the next sort of 45 minutes. We're going to walk you through an activity that we've made. Just out of interest, we're not expecting anyone to be a technical expert, but is there any teachers or educators taking part today? Okay, a couple of people. Any technologists taking part? Okay, a few technologists. Any computer programmers as well? Good, yeah. So yeah, you won't need to be a technical expert to take part today. We've designed this workshop so it can be accessible for everyone. Yeah, and we'll have time at the end to sort of talk about some questions as well. You can hang about and chat to us as well. So, every day, data is used to make decisions that affect us. So thinking about trivial things like our favourite music app as well. So if you're using Spotify or Apple Music, the songs that you choose to play and the songs that you choose to skip as well are all your personal choices. That's all part of your data. And then that data is used to make decisions about what song is going to be played next for you as well. Similarly with YouTube, the videos that you choose to watch, what you choose to like or subscribe to, are your personal viewing habits. And that data is used to make decisions about what video is served to you next. But even important things like whether you might get interviewed for a job or how much money you can take as part of a mortgage will be based on personal data about you.
And these decisions, they get made by algorithms, so something that's going to be familiar to everyone in the room. And sometimes these algorithms are sets of rules that experts in their field have created. So they might be things like rules-based algorithms that are useful for solving problems, where we understand the data, we understand the problem, and we can create rules that are going to cover every eventuality. But sometimes the problems aren't quite so clear, and that's why we're using more things like machine learning, generative AI, and other machine learning systems. And that's really useful when we've got a variety of data types and a more complicated problem, because they let us find an answer of sorts, but it's not quite as clear how it works.
So today we're going to be sticking not to the machine learning algorithms, but to rules-based algorithms. And these decision-making algorithms that we're talking about can have benefits, but they can also go wrong. So, for example, an algorithm used by a university or a school or an exam board might decide that you've failed a test, or an algorithm that is used by a bank might decide not to loan you money. If you can't see how that algorithm works or understand who are the people who are designing it, is that fair?
So throughout the day, we've been hearing from lots of people about how tech and AI has the opportunity to really help people, but also how tech and AI has the ability to harm people. And as technologists, it's kind of on us to be thinking about this as we go about our lives. And we've got to ask ourselves, are we doing the right thing? Is this the right solution to the problem? And keeping ethics at the front of our brains, asking ourselves, is that fair? Because we're facing a future where increasingly these algorithms are making more important decisions about our lives. And we need to know that we can trust both the tech and the people behind that tech. So today, we want you to explore and question and understand how personal data gets used to make decisions that affect us, and how those decisions then go on to affect the people that they are about.
So here's the challenge for this afternoon. We're going to get you to create your own algorithm that uses data. So we're all going to be taking on the role of algorithm designers, or maybe a little bit of software engineering as well, depends on how hands-on we get. So just out of interest, do you think you can be fair? Put your hand up if you think you can be fair. A few people not so confident? Okay, that'll be interesting. We'll see how that goes. To test it out, once you have designed your algorithm, so collectively we're going to take responsibility for that algorithm, and then we're going to run it against a data set of children from a school, a synthetic data set of children from a school, and we'll see what kind of impact your algorithm that you design has on those people and seeing the results. So, to get you into the right frame of mind, so we're talking about ethics, trustworthy, inclusiveness. I want you're going to be designing an algorithm today, and I'm going to suggest that you join us in taking a pledge with us that you will try to be fair. So place your hand on your heart. You're going to repeat after me. I will be a responsible digital citizen.
I will be a responsible digital citizen.
I will use technology in a fair and transparent way to help, not hurt.
I will use technology in a fair and transparent way to help, not hurt.
I will spot and fight back against unfair algorithms.
I will spot and fight back against unfair algorithms.
We've done it. We've taken the pledge. You have to be fair now. You have to be fair. We've made that pledge. Okay, Daniel, what are we going to do?
Yep. So, in fact, this workshop that you're working today, this challenge, we actually wrote for primary school pupils. This is something that we did with the Children's Parliament at one point, but we thought it'd be really interesting to put you through the same challenge as well, to see how you respond to it, and to see the impacts of your decisions and how they were different to the pupils. So you're going to be doing a task that's designed for primary pupils, basically, this afternoon. So this is the ethical dilemma that we've got. We are working for a fictional school, and our fictional school has 500 pupils at it. And the school has been offered a treat, but they can only offer this treat to 100 of those pupils. So we've got to find a fair way to do that. And our reward are tickets to a new mini golf place. So there's 100 tickets to give away, but there's 500 pupils at the school, so not everyone can go. Now, the school's given us a bit of a brief. They've said that the ticket should be a reward. It shouldn't just be random. We want to be rewarding pupils for this. But they haven't told us how we should do it, but they've told us they'd like us to use a decision-making algorithm to do it. So we need to decide who we're going to give these tickets to. So for our golfing problem, we need a fair way, end of the day, to choose what people should get the free tickets.
You're attempting a stand-up joke?
Yeah.
Okay.
I should know better.
Perfect. Okay, so let's start a bit of a discussion then. So I want you to try and just chat to the people beside you. I'm only going to give you a minute to do this. And I want you to imagine, I want you to try and answer this question. How would you choose the group of pupils whose behaviour we should reward? What types of behaviours would you sort of think suggest someone who should get a treat? Now, I know that today we'll all be thinking, because you're at this conference, so you're probably quite interested in ethics and fairness and stuff like that. But if you want to take on the role of a different persona this afternoon, so maybe you want to see yourself as a pupil at that school who thinks that they should go, or maybe you're a really conservative, strict head teacher. Okay, so maybe you don't have your own hat on, maybe you're going to role play as someone else for this afternoon. We won't judge you for that. But chat to the people beside you. I want you to try and decide what type of person do you think should get that treat, should get that reward. So I'm only going to give you 1 minute. Go for it. Set a timer for 1 minute.
Who's the disciplinarian?
seconds. 30 seconds. Ten seconds. Okay, stop there. Stop there. Stop there. Let's have a few suggestions. What types of people do you think should be rewarded at this school? Yes.
We said the children who have never been rewarded before.
Children. Okay, so children who have not been rewarded before over the past 5 years. Okay, yeah. Any other suggestions?
I actually suggest children who are kind to other children.
Okay.
The disciplinarian here said it should be based on academic needs.
Okay, so
There's a conflict.
yeah, there's a bit of to be kind to other people. Yeah, yeah. But we know that happens in schools, don't we? We know that these are both like types of things that happen. That's great.
I was thinking people like improve, retain the best for them.
Okay.
People who succeed improvement, showing that they've made development.
So the best progression.
To their progression.
Yeah. Wow.
Not necessarily an academic. Yeah.
Oh. Yeah. You're just going to have a hard time when we're about to discriminate against people in a minute here. Yes.
Other children performing better at school may also be ones that have come from a more stable home environment or
Yes.
wealthier socioeconomic backgrounds, so they're getting more treats to begin with.
Yep.
Children therefore
That's it. And we know as adults, and especially like when we've run this for teachers or youth workers, we know that it is much more complex than you think. We know that there's a lot of connections here that we understand as adults or parents, but you may not understand, or it might not be obvious if you've not had those experiences. Would you like to see what the children said? First, Daniel, what did they say?
So this is what pupils told us. So we've run this activity with just over 1,000 pupils now, and there was a few trends that came up. So these are some real answers from pupils who have done the activity. So some people said that pupils who have been working hard should get the reward. So they want to reward sort of people who are taking part in things in class. Some pupils told us that kids who have less money should get to go. So I think that's building on one of the points that we just heard there, that perhaps some pupils naturally will have less opportunities to do things like this. Some people said that pupils with the most merit points or house points should get to go. So house points might get given for doing good turns in class. It might be other sort of behaviours that we want to promote. Some pupils told us just explicitly the best behaved pupils. They tended to be the well-behaved ones. Some pupils refused to answer the question, and they said it should be random or a lottery. Yeah. They didn't want it to be based on something. They thought the fairest thing was for there to be no rules involved.
But we're not going to do a lottery or make it random, because we want to design an algorithm that rewards people based on decisions that we make. So we're going to do this using a points-based algorithm, Daniel.
Yeah, so we want to treat all the pupils the same way, against the same rules, and we're going to run the same code against their data. So we're going to use a points-based algorithm. Like we said, we're going to use some Python code to make the decisions. But before we do that, we should run through how the algorithm's going to work. So some of you are already suspicious of us using an algorithm. Some of you are maybe suspicious that a points-based algorithm isn't the right way. Some of you have probably also noticed a points-based algorithm usually isn't considered AI, probably not in this context, but it's a useful way of sort of introducing algorithms because it is a transparent algorithm for once. So how it's going to work is that all the pupils are going to start with 0 points. And depending on some data about them, so it might be things like attendance, it might be grades, behavior, house points, age, we've got a bunch of things to choose from. We're going to choose which ones of those we want to award points for. And we're going to award points based on that data. And then we're going to rank the pupils from most points to fewest points. And the top 100 highest point scoring pupils, they're the ones that are going to get the reward. So that's our algorithm.
And points-based algorithms are used in real-life decision-making things every day, and they can be important things as well. So, for example, people who want to move to Australia for work are scored before being granted a visa. So the points that they are given are based on personal data about them, things like their age, their ability to speak English, the level of qualifications that they have as well. And applicants need to score a minimum of 60 points if they want to get their visa granted. So our points-based algorithm isn't going to be as life-changing as that, but we're still going to be using some types of data that we can use in our algorithm. So think about the types of data that a school might already be collecting and holding about their pupils. So something that it might hold the record on is, have they passed their most recent maths test? Or we might have information about, have they recently been given house points, or are they frequently late to class? And for each piece of data about them, we're going to decide how much impact it has on whether they're going to get that treat or not. So Daniel, how are we going to allocate these points?
Yeah, so for each piece of data, we're going to decide how big an effect it has on the pupil's chance to get tickets. So let's look at maths test. So let's say that you thought passing your maths test was the most important thing when it comes to going to mini golf. If you thought that, you would give it 10 points because you would want it to have a huge influence on the result of the algorithm. If you thought it's something to be somewhat rewarded or considered as part of something, you might give it 3 or 4 points. So it still has an influence, but it's maybe not the biggest influence. Or if you think that we shouldn't be considering maths at all, then we'd give it 0 points. So it's not going to have any effect on the final result. And in fact, you want to go the other way and take points away if you pass maths.
Yeah.
So maybe you want to do
You could
something.
say, we don't like people who are good at maths.
Yeah,
We're going to not allow them go to golf.
Then you could give it some negative points.
Yeah. There may be some people in the room that have that approach tonight. Let's see.
Yeah. So we've had about 1,000 pupils do this activity online, and we can see the points that they've given to different pieces of data. So one of the bits of data that we gave pupils to work with was attendance data. And we're curious to see, like, okay, what do pupils think about attendance? Like, is that something to be rewarded or is it not? And actually, the vast majority of people said that it was. And in fact, quite a lot of people said that it was really important to give it 10 points, which I found quite interesting. Most people gave it a few points, and there was a sizable minority that said that there shouldn't be any points rewarded.
So we asked them, like, why did you decide to give it that level of points? Why was that? Why did so many of you say that good attendance should be a big factor in whether someone gets a treat? And they said to us things like, well, I think if it shows that you turn up on time, then you're being respectful, and they wanted to sort of reward that good behaviour. But other people said things like, well, it's not always the pupil's fault if they're late. Sometimes it could be the bus, or it could be a parent or something else. But most pupils seem to value attendance, that was doing this would be a really important thing or something that should be considered. There was very few people who said that it shouldn't matter either way. And I think what that can already show you is that if you even just look at the spread of people who are in a school doing this, you can already see that different people's opinions, their own beliefs, are already going to have an influence on the way that algorithm is going to be designed.
This was interesting when we did it with youth leaders. I don't think there was a single youth leader give it anything other than 0 for this one, which was interesting as well. Very different to the kids. So these are the pieces of data that we're going to use in our algorithm. We've got 8 pieces of data that our fictional school has given us to play with. So we can decide whether we want to give points or subtract points for meeting one of these conditions. So in fact, for meeting all of them. So if a pupil's in the upper school, we can give them some points. So you might want to advantage pupils who are older, who might be leaving the school sooner, or they're more mature. You might want to reward attendance.
You can guess which pupils felt as if the older pupils should get the advantage, yeah.
Mm-hmm. We've also got house points in there, passing maths, passing English, whether they've had detention recently, whether they have additional support needs, and also whether that pupil is late regularly.
So I guess these are the only variables that we're going to allow you to work on. And what you're going to do is, for each one of these, you're going to decide a value between -10 and +10. -10 means that you lose points. 0 means you're not going to have any effect on it, and any positive number means that you're basically encouraging that. Yeah. And if it's +10, that's the highest value. The way that we're going to do this is we're going to give you an access to the website so that you would be able to code this yourself. But I think today, Daniel, what we should just do is collect everybody's design decisions. We'll implement it first, and then people can play about with the code.
Sounds good. So what we're going to do now is we're going to collect in your scores for the algorithm. So you could do this on a phone, or you could do this bit on your laptop. But you're going to head to Mentimeter, and we've got a code here. And you're going to give your points and submit them.
I'll just check that that's loading as I expect. So once that's loaded on your phone or your tablet or your computer, you'll see it's a bunch of sliders. So this is the point where we'll give you maybe, 2 minutes?
Yeah, 2 minutes.
2 minutes to move the sliders and then hit submit at the bottom to submit your final results. So about 2 minutes now, please. The concentration levels, I can feel it. Is this one mine?
Yes. I feel like an invigilator just walking around in the silence.
Just over a minute or so. I think, yep, 14 responses so far. That's good. We won't bring them up yet until... So remember, you can either play this as yourself, or maybe you're playing the persona of a different character. So I'll take a picture of the results when they come in. Okay, about another 30 seconds or so. Is there potentially people playing online as well? Maybe?
Maybe.
Could exactly, like, yeah, if we'd set everyone up in rows and treated it like, you know, and also, like, could someone looking over your shoulder affect what you choose? Is it truly anonymous? Okay, I think we're at time. Okay, so Daniel, let's have a look. Oh, this is quite interesting, actually. It's quite spread out. So I'm seeing here, I'm just going to look at some of the peak points here. So it looks as if we're not biasing anything to do with age, so that's not having a big effect here. But the things that are standing out to me is if you've earned house points for good behaviour, it seems like a lot of you have given some weight to that. That was something that happened a lot in the school classrooms as well, because I think pupils know that house points were, well, who was going to be awarding them? It was probably going to be teachers who were doing that, and that maybe in an algorithm like related to school, a teacher should have like they've got the subject knowledge, they should be making a fair decision about that.
We're almost passing the decision back to the teacher
yeah.
With our algorithm.
Not all algorithms in education put as much weight on the teachers necessarily. Okay, and down this one down here, Daniel, the detention seems to be a bit of a negative.
Yeah, which again, in the schools, so detentions are given really infrequently now in Scottish schools. So if people had a detention, that was seen as like really bad by a lot of their peers. So actually,
-10?
Yeah, it was a -10 for like most pupils that have done the activity, which again, interesting, because the teachers said that they maybe want to have a tiny effect, but they wouldn't want to then further like exclude pupils on that. So it doesn't surprise me that that's the most negative here.
It's like a death sentence in school from the pupils' point of view. If you got a detention, you were in trouble. You weren't getting on that trip. Okay, interesting. Okay, this is one that I didn't expect. See, it looks like you have given pupils with additional support needs are being given a bit of an advantage in terms of we've given them 3 points here, Daniel.
Yeah.
What shocked me was that when we did this with schools, most school pupils said 0 for additional support needs. So the reasoning behind it when they spoke to us were they saying things like, everyone should be treated the same, and they didn't think that because someone in their class or because they had additional support needs that they should get any particular advantage. Again, I think this is something different where people who are adults or working in, teaching or education or youth work understood that it's not always as clear as that, and you can't always just say everything should be fair for everyone all the time. But that surprised me about the number of pupils who don't give any, quite consistently say no advantage, or not making any allowances.
Yeah, maths and English is interesting because we can look at the histogram and they're almost the same, but there's a very slightly longer tail on maths, so the maths result has ended up slightly higher. Again, this happened with the pupils as well, actually. Maths always seems to go slightly higher, and sometimes the pupils told us, it's because you need to do some maths when you're doing mini golf. Just, okay, I guess perhaps that's true, but it's interesting. I'm not surprised in the room full of technologists that maybe maths is slightly higher.
I think humanities is an underplayed element of mini golf.
Yeah.
Let's see. So let's take these results, and we're going to put this into our computer program now. So we've already written the code for you. Now, as Daniel loads it up, we've using Python programming today. So we've written the code in Python so it's easy to read and understand. If anyone's written in Python before, it looks kind of English-like. The code is free and available for anyone to use. So if you're a software developer, you fancy playing about with it, we'll give you the link. You can use this. So the code's on the left-hand side, and in the second tab here, we've got our pupils. So this is a list of 500 pupils at this school, and it's got their personal data. So it's got their first name, last name, their age, whether they have high attendance, whether they have high house points. Now, although this is fictional data, it is based on the real averages that you would get in a Scottish school. So it is about the same distribution of ages. You looked up, Daniel, the number of times that, absences and how that linked to passing and stuff as well.
Yeah, it's based on national primary 7 averages for sort of lateness and attention giving and test passes, etc. So it's somewhat representative of primary 7s.
If you scroll back to just the first bit where it has their names, okay? Just interesting. This is the first time that you've seen the names of the people, but you've already decided how we're going to decide between them. So, how is Marie going to do? How is Larry going to cope with this algorithm? What's going to be the result for them?
Yeah, we've not asked the young people, as they told us they wanted to be asked earlier.
Yes.
So
hopefully they've all went home before we wrote an algorithm without them. Okay, so Daniel, you're going to change these figures here. So I'll look up what people said roughly.
Okay, Craig. So what we need to do here is we just need to change the weights in our algorithm. So it's a series of if statements, basically. If the condition is met, then we give them points. We just add it onto their total, and it just repeats through it 500 times, once for every pupil. So, Craig, the first one in here is if they're in the upper school.
Yep, let's give them 0.
0, okay. How about if they have high attendance?
So that's 2.5. Do you want to round up or down?
Let's round up for drama.
3. Okay.
House points?
6.
6, okay. How about maths?
3.
3. English?
2.
Detentions?
Detention, -3.
-3, okay. If they have additional support needs?
3.
3. And if they're frequently late?
-2.
-2, okay.
Okay, so we put those weights in. Everybody has 0 points to start with. Daniel's going to run the code against 500 people. So, wow, that was quick. So it didn't take that long. So we have our ranking here. So we have everyone in position 1 to 500. So Daniel, tell us who's in what position, who's going, who's not going.
Well, Louis is not going. Louis has -3 points.
Oh.
So let's scroll up to the top. Who has the most points? Queenie. Queenie must have met all the conditions. Queenie's got 17 points here. And then we've got a whole load of people that are on 14. And then if we scroll down, so you've got a bunch of people on 12, some on 11. Is there a clean cutoff after
Yeah, so
100?
who's the last person who's getting to go on the trip?
So we've got a bit of an issue here.
Oh, there's quite a few 11 points. Well, I think we'll just have to, I think Hester, yeah. There's some these people could have the right to appeal, maybe, Daniel, or see. But I think we'll stop at, what was it? Who was the 100th, roughly? Esther? Yeah. Okay, so in general, has your algorithm worked? Yes, it has allowed us to take that list of 500 pupils and manage to cut it down to about 100 or 110 people who we can then offer tickets. But is your algorithm fair? Is your algorithm ethical? Let's find out. So, Daniel, there's lots of different ways that we could have designed this algorithm. If we'd tweaked some of the values, maybe individually, you would have had different results. But let's compare it to, let's look at some individual pupils in the school, Daniel.
Yeah, so let's try and see if we can find Gemma in our list. So Gemma has been off school quite a lot because her mum's been ill and she's been having to care for her. So let's see how our algorithm has treated Gemma.
Okay. Gemma. So you're going to go Command F, and you're going to look for Gemma.
She's in position 413.
So
That's bigger than 100.
Yeah.
So Gemma's not going. So why did you do that? Why have you decided Gemma can't go? Gemma couldn't help that she wasn't at school.
How did that happen? You did the pledge. Like, tell me. What was that, attendance? Yeah, she had low attendance, yeah. So we weren't punishing people for having low attendance, were we? No, but what we did was we rewarded people quite a lot who had good attendance. So you didn't deliberately try, you didn't deliberately try and not give Gemma a treat, did you? No. But interestingly, the way that we then advantaged people probably did cause, so yeah.
The other things as well, some of the other things we gave points for, attendance might affect too, like house points. If you're not at school, you're not earning house points. So there's things like that. So we might be rewarding attendance twice here. Perhaps.
Okay, Daniel, I've got another person then that we can look at. So let's assume that maybe Gemma was a one-off. Okay, so I've got a different pupil here. So Artem, okay? So Artem is a refugee. He only recently started at the school, and he joined after the last class tests were done, so he doesn't have class test results. So where did the algorithm put Artem? Okay, 254. Okay, so Artem isn't getting to go either. Okay, so how did that happen?
So you may not have been present in some of the tests.
Yeah, that's exactly it. So again, he didn't do the test. We weren't disadvantaging them, but he didn't have the opportunity to get those points as well to put them there. Are you happy with the way that your algorithm works now? Would you make any changes? Does anyone fancy changing any of the values?
The challenge for me is that I think all the data fields we're using to assess it on are the wrong ones.
Yes.
That's the challenge. So
Yeah.
to weight them differently isn't going to fix it for me. It doesn't have,
Yeah.
like I know the school my daughter goes to knows the kind of sympathy area from
Yeah.
kind of level of disadvantage they're in. That's a criteria I might use in terms of trying to budget people who are less likely to have treats elsewhere in their life. I don't know if any school would capture the data on parent responsibilities of kids that's very badly documented in the whole.
Yeah.
Yeah, for me it's the data going in is the problem. Yeah.
Yeah. So you might be looking for other data sets or other elements that you might want to use as part of that algorithm as well. Any other adjustments or changes that you would make? Yeah.
I mean, it was raised previously before we got into the exercise about like the personal trajectory, and so if there was historical data, adding in to see, okay, this person has improved,
Yeah.
From a certain baseline and whatnot, that can be a way to enhance even with the limitations of these fields.
Yes. So maybe you would take a previous snapshot of the data set, comparing it, and then, yeah. This is a lot of over-engineering, isn't it, for a class trip?
There's something, it's like, why bother having criteria even in there if it's just going to make no difference to the score?
Mm-hmm.
Like, if the net result's 0, why bother recording it?
Yeah. Mm-hmm. Yeah. And I'm sure you have all had situations where just because you have data on something, sometimes people really want to use it or find a way to use that and calculate. Yeah. And even in this simple example that we've got here, we've found examples where it's not behaving the way that we expected it to behave, or we've already found some trivial sort of problems with it as well. And I suppose what we're pulling out with the school pupils, but also with adults that we do this well, with the sort of the feeling of getting to play about with this and try it.
Craig?
Yes?
I've just put a short URL with the Python code. Mm-hmm. So if any of you want to see how your weights affected the scores, then I'm going to put it up and you can,
Perfect.
Since we've got laptops, let's use them. So if you head to tinyurl.com/unfair algorithm, then that will bring up the Python code, and you don't need to have anything installed. The code will just be there in your web browser, and you can try out your weights as well.
So we'll give people a second to load that up, and then maybe we'll do the last couple of slides, and then we'll allow people to play about
on it.
Yeah. Sounds good to me. So it's tinyurl.com/unfair algorithm. I was trying to misread that in some way, but I couldn't. Unfair. I'm coming up with a new talk, Daniel. It says there, like, unfair. You can't have unfair without AI. Okay, so we'll bring that back up so that you can play about with it in just a couple of minutes again. But just to sort of summarize some of the things that we learned about this when we were doing it is that it is really easy to make decisions using data. Like, you've seen us do that. It is easy to collect data, and it's easy to write little programs that can make decisions based on that data. However, making a fair algorithm is going to be hard, and we might unintentionally disadvantage certain people as well. And what that gets me thinking about is we know that the relatively easy part is some of the technology side of it as well. The hard part is that we need more people who understand what could be the potential consequences and when and where to use this technology as well. And that's something that I hope that when we go out to do this with schools or other groups, or even just people who work in companies that are using these technologies but are not necessarily the sort of technical experts, that we can encourage them to get more involved in these processes as well. So, the next steps for this, Daniel, if you would like to play this activity and more about it, you can go to our website, which is cyberskillslive.com. We'll bring back up the other code as well in just a few minutes. But if you also work with people and you would like to have this sort of experience with your team, you can come and chat to us at the end. We go out to workplaces and deliver this type of thing. And Daniel, for those of people who are interested in other ethical dilemmas.
Yeah, so we've been working on a few different workshops that teach ethics in tech, and our latest one that we've just put out is called Unmasking Data Disasters. So in that one, we look at anonymized personal data, basically, because every day companies, governments, research bodies are using anonymized data to kind of do research. But is your data as private as you think it is? Well, actually, there's been many cases where it's actually possible to re-identify people in a big data set. And quite often, if you find the puzzle or the key to doing it, it can be really trivial to do that. Mm-hmm. So in that activity, we take some supposedly anonymous data sets that seem impossible to reverse, but then we show these school pupils, here's how you can actually re-identify the individuals that are in that data.
So both that activity and the one that we've done today, we've been doing in partnership with the Data Education in Schools team, which is part of the University of Edinburgh as well. So hopefully that's given you the chance, and I think we'll maybe bring up the unfair algorithm as well to allow people to work through it. That ends the more formal side of the workshop, but Daniel and I are going to be walking about. If you've got any questions, you want to chat to us about anything. But thank you for joining us to, can you code a fair and unbiased algorithm? Maybe.
Not if we're
Not today.
deciding how it works.
That's great. Thanks very much.